In number 9, we want to find the average value of this function, y equals 3x squared plus 1 on the interval 1, 3. So we just have to remember the formula for the average value, let's say of f of x on, let's say, AB, interval AB. That's equal to the integral from a to b. And then on the outside we have 1 over b minus a. And then we have f of x dx. Okay, so let's use that formula. And we have our average value. Our average is equal to 1 over 3 minus 1 times the integral from 1 to 3. 3x squared plus 1. Alright, so that's 1/2. 3x cubed over 3 plus x. Evaluated between 1 and 3. Okay, these cancel. And that's 1/2. 3 cubed is 27 plus 3 minus 1/2. Now we're substituting in 1, and we have 1 plus 1. Okay, so this is 30. Half of 30 is 15. Minus half of 2 is 1. So we have 14 for the average value. In number 10, we have a rectangular fence. Yeah. Okay, number 10 is an optimization problem. We have a fence that's constructed from material that costs $3 per foot on 3 sides and $10 per foot on 1 side. So the fence, that's a rectangular fence. It's enclosing a rectangle. So let's draw a picture of that. Alright, let's label these two opposite sides x, and let's label these two sides y. Okay, and we have the area enclosed is 100 square feet, so that means xy is equal to 100. Now, what we want to do is minimize the cost of the fencing. Well, the cost, let's say if these 3 sides are $3 per square foot, then that means that, let's say this side costs 3x, and this side costs 3y, and this side costs another 3x, and then the last side is $10 per square foot, so the last side is 10y. So this is the cost. Let's just rewrite this. The cost is equal to 6x plus 13y. Alright, we want to minimize the cost, so we want to, whatever we want to minimize, that means we take the derivative and set it equal to 0. And c is in terms of 2 variables, so we'll eliminate y first using this equation. We have y is equal to 100 divided by x. Alright, so let's do that. So c is equal to 6x plus 13 times 100. That's 1300 divided by x. Okay, that's 13y, and this is y 100 divided by x, so that's 1300 divided by x. Okay, take the derivative and set to 0 to get the value of x where c is minimum. So there we have 6 minus 1300 over x squared. That's the derivative. And if we set this equal to 0, set it equal to 0, and we get 6 is equal to 1300 over x squared. 6x squared is equal to 1300. X squared is 1300 over 6. And we get 1300 over 6. And we get x is the square root of 1300 over 6, and that comes out to approximately 14.7. Okay. So those are the dimensions of the fence. So the fence is, let's see, what dimensions should the rectangle be? So one side is 14.7, and the other side, y, is 100 divided by 14.7. And that would be the units or feet. Okay, we just have one other very quick question, that added on question. I called it question 11. It has to do with the second part of the fundamental theorem of calculus. So here, number 11. So remember the second part. The second part of the fundamental theorem of calculus went like this. The derivative with respect to x of the integral from a to x of f of t dt is equal to f of x. So the particular question is as follows. What's the derivative with respect to x of the integral from 2 to x squared of cosine t dt? So that would be, instead of f of x, it's going to be cosine of this, cosine of x squared. And we're taking a derivative here, so we multiply now by the derivative of x squared, so it's multiplied by 2x. And that's it. That's it for our review. Okay, so good luck studying, and check on Blackboard for the written out solutions. Okay, see you Monday.